Hi everyone, this is the continuation of quantum chemistry classes. In this video, we shall learn about application of Schrodinger wave equation to hydrogen atom. It's a very important concept because we are well aware that if you consider an atom, in that atom there will be certain definite number of protons and neutrons present in the nucleus, and around the nucleus the electrons are revolving in circular path. And if we want to understand the exact characteristic properties, mainly the reactivity of an atom, we are supposed to know the exact energy possessing by an electron and the position of the electron, that means the distance of the electron from the nucleus, and the region of maximum probability of finding the electron, that what we simply call as orbital. So we should know the exact shape of that orbital, and we should well understand the exact energy of the state of an electron. So in order to know all these things, we are supposed to solve the Schrodinger wave equation for the hydrogen atom. And in this video, we shall learn how to solve the Schrodinger wave equation for the hydrogen atom and what information we can get from that particular solution. And now we shall get into the topic. So if you consider an atom, that executes the rotational motion around the nucleus, and we know that around the nucleus the moment of electron is circular, means it is exhibiting the rotational motion, and the moment of or the rotation of electron around the nucleus is not restricted for only one dimension. The electron is revolving around the nucleus in 3 dimensions. So it is not that much easier to restrict the moment of electron, or it is not possible to measure the moment of electron by considering a normal Cartesian coordinate, that is x, y and z. Since the electron is revolving in circular path in 3 dimension, so the moment of electron around the nucleus is spherically symmetrical, so that the position and the wave function of that electron is supposed to be expressed in a spherical coordinates, also called as polar coordinates, but not in Cartesian coordinates. That means we are supposed to change the Cartesian coordinates that are present in the Schrodinger wave equation, that is x, y, z. The Cartesian coordinates are supposed to be changed to the polar coordinates, what we also called as spherical coordinates, nothing but r, theta, phi. So where r is the radial function, theta and phi are angular functions, right? And the relationship between this Cartesian coordinates x, y and z and the polar coordinates r, theta, phi can be easily established, and for that purpose we shall draw a simple diagram. So this is the way, this is the Cartesian coordinates, so x, y and z. So let me consider this is as x, y and z, the 3 Cartesian coordinates. Okay, and let us consider a point in a space, say P. Okay, and its projection along the xy plane, the projection of the point P along the xy plane can be taken in this way, and let me take that as P prime. Okay, so now shall take the complete 3-dimensional coverage of the projection. So this is the pictorial presentation we need in order to understand the establishment of Cartesian coordinates into polar coordinates. And here this is the origin, and the distance between O and P is R. Okay, and let us take this point as P, and this will be the X, this is the Z, and this is Y point. Okay, so we can take This is y, this is x, and this is along z axis. And here the, as I said, the point P is the simple, it is a point in the space. P is point in space, and this P prime is the projection in the xy plane. And thereafter you can observe OP is equals to R, and this one ZOP can be taken as theta, angle ZOP will be theta, and angle XOP prime can be taken as phi. XOP prime will be phi. And you can observe the thing PT is R sine theta, and PT is perpendicular to z axis. Therefore, the projection OP prime and OP will be, PT and OP prime will be almost similar. Therefore, this can also be taken as R sine theta, and this is perpendicular to the PT is perpendicular to this z axis. So, this ZO will be taken as R cos theta. Okay. So, these are the complete pictorial presentation that we are supposed to follow in order to convert the Cartesian coordinates into polar coordinates. And here we already said OP is equals to R, angle ZOP is theta, angle XO prime will be phi. And as I said, the PT, this one, PT is perpendicular to Z axis. PT is perpendicular to Z axis. Therefore, PT is exactly equals to OP prime, and that's equals to R sine theta. So, with the help of all these things, we can write the projections of X, Y, and Z axis in terms of polar coordinates. So, that is, now we can write X is equals to OP prime cos phi. So we know that OP prime is equals to R sine theta. Therefore, X is equals to R sine theta. R sine theta cos phi. And Y is equals to this one. Y is equals to OP prime sine phi. Since OP prime is equals to R sine theta, therefore R sine theta sine phi. And Z, here you can observe, that's equals to R cos theta. That's nothing but OT, that is equals to R cos theta. These are the conversions of the Cartesian coordinates X, Y, Z into polar coordinates R, theta, and phi. So in this way, we can easily convert the Cartesian coordinates into polar coordinates. And our main motto is to apply the Schrodinger wave equation for the hydrogen atom, right? So hydrogen atom is the very simplest of all the atoms, wherein we are having only one proton at the nucleus and one electron is revolving around the nucleus. And the atom is a three-dimensional system, and for that three-dimensional system, the Schrodinger wave equation can be applied. That means for hydrogen atom, Schrodinger equation in 3 dimensions is given as H cap xi is equals to E psi. So that we already derived in our last videos. So we know that here H cap is called as a Hamiltonian operator. So H cap is Hamiltonian operator, which is given as minus H square by 8 pi square m del square plus V. So this is the complete form of the Hamiltonian operator, that is H cap, right? And here we have one more operator, that is del square, that we call it as a Laplacian operator, right? So we know that del square is equals to dou square by dou x square plus dou square by dou y square plus dou square by dou z square. That is the Laplacian operator del square, and V is potential energy, which is given by minus Z E square by 4 pi epsilon naught R. So these are the values of del square and V, right? So we are already aware of that. And here we have the Cartesian coordinates x, y and z. So this del square is supposed to be converted into the corresponding polar coordinate, that is in terms of r, theta and pi. So by introducing the polar coordinates at the place of Cartesian coordinate, that is x, y and z, the term del square will get changed. So I'm not going with the whole and soul application of all these things. It's a too lengthy process. Let me give the direct value of the del square. So let me say, by introducing polar coordinates del square will changes to, so it will give like this, del square that's equals to, so 1 by r square dou by dou r into r square dou by dou r plus 1 by r square sine theta dou by dou theta into sine theta of dou by dou theta plus 1 by r square sine square theta dou square by dou phi square. So here you can observe, in here del square is having x, y, z, that is Cartesian coordinates. But here you can observe, by introducing the terms x, y, z in this expression and performing the partial differentiations, we have got the term that is r, theta and phi. And now this condition is supposed to be introduced in the Schrodinger wave equation, that is h psi is equals to E psi, and here we are also supposed to introduce the value of potential energy, that is V, that gives minus Z square by 4 pi epsilon naught R. So by introducing the value of del square and the value of potential energy V, the Schrodinger wave equation will get changed. So that we shall see now how the Schrodinger wave equation will convert on application of the values of del square and potential energy. And now shall say in this way, so minus h square by 8 pi square. So there we got m, but here we shall introduce mu, which is reduced mass, because we know that, so if you consider a single particle, we can go with only single mass m, but when you consider atom, so we'll be having both proton as well as electron. So we are supposed to take the mass of electron as well as proton for the consideration. So therefore we should go with reduced mass. So, and the value of del square is 1 by r square dou by dou r into r square dou by dou r plus 1 by r square sine theta. You can observe here we have only r square, and here we got one more addition, that is sine theta. 1 by r square sine theta dou by dou theta into sine theta of dou by dou theta plus 1 by r square sine square theta dou square by dou phi square of xi minus, at the place of potential energy, that is V, that is Z E square by 4 pi epsilon naught or xi, that's equals to E psi. This is the complete Schrodinger wave equation on introducing polar coordinates at the place of Cartesian coordinates. Let us consider this as equation number 1. And now here I said this is mu. Mu is reduced mass, which can be calculated as, it is mass of electron into mass of proton, which is present in the nucleus, since hydrogen is having only one proton and one electron, by mass of electron plus mass of proton. This is the way we can calculate the reduced mass. Okay, and in order to get the details of the hydrogen atom regarding electron, so we are supposed to solve this Schrodinger wave equation, that is 1. The equation 1 what we have generated, this is supposed to be solved. And in order to solve this, we are supposed to go with the method of separating the variables. I mean, here you can observe we are having r, theta and pi, and here you can observe, so we are having r term, theta term, we have mix, r term, phi term, we have the mix. So we need to separate the individual variables separately, so that we will be getting ordinary differential equations wherein each differential equation will be having one variable. So what we are supposed to say, in order to separate the variables, or else let me say in this way, the solution of equation 1 can be obtained, the solution of equation 1 can be obtained by separating the variables. By separating the variables, and wherein separating the variables, during which we will be getting, here we have the partial derivatives, that is dou, and we will be getting normal differential equations. So that for that purpose, in order to separate the variables, we are supposed to introduce one small condition, that is xi in terms of polar coordinates r, theta, phi should be taken as r of r, which is called as radial function, p of theta and f of phi, where r is radial function and p and f are the angular functions. So I can write in this way, this is radial function, r of r is radial function, and p of theta and f of phi are the angular functions. Angular functions. Okay, and now we have to introduce xi. At the place of xi, we are supposed to introduce r, p and f in equation 1. So now we shall see how that could be happened to. So now here you can observe, so in this equation you can observe, so this minus h square by 8 pi square mu is supposed to be multiplied for this whole term. So we shall do the simultaneous multiplication as well. We shall introduce r, p and f at the place of xi, wherein xi is multiplying for the whole term. So now we shall go with the same. So now the equation will get changed on multiplying the h square by 8 pi square mu as well as the r, p and f. So the equation will get changed minus h square and by 8 pi square mu. So r, p, f will come. So p and f will be taken out. R square dou by dou r. And hope you can observe here it's the radial term. So for that reason, so when we are writing this thing, so when we are multiplying the psi, that is r theta phi, when we are introducing r, p and f, since it is the radial term, so we will be taking r term in, and the angular terms will be placed outside. Same thing will we do here. So here it is theta, so p function will be taken over here, and r and f terms will be taken out, and here it is the phi term, so f term will be taken inside, and r and p terms will be taken out, and the same thing we'll do over here. So now we shall see how that actually happens. So minus h square by 8 pi square mu pf has been taken out, r square dou by dou r into r square, sorry, the normal differential equation d by dr. So r square dr by dr minus h square by 8 pi square mu r f by r square sine theta d by d theta of sine theta of dp by d theta. And here the radial function, angular functions, see r and f have been taken out, and since it is the p theta term, so p has been taken inside, minus h square by 8 pi square mu r square sine square theta, and the last term is the phi term, so r and p term will be taken out, so d square f by d phi square, and the potential energy term, that is minus z e square by 4 pi epsilon naught r, and at the place of xi we will be taking r p f, that's equals to, so we have e xi, e at the place of xi we will be taking r p f, and this will be taken as equation number 2. And this has to be reduced to the simplest form by, we need to separate the variables r, theta and phi, and for that purpose, in order to separate the variables, so in the equation number 4, the whole equation number 4 is supposed to be multiplied with the one term, that is, sorry, equation 2. Equation 2 should be multiplied. So multiply the equation 4. Equation 2 is multiplied with minus 8 pi square mu r square sine square theta whole divided by h square. So with this term we are supposed to multiply the whole equation number 2. So here in each term we are having negative sign. So here also we are taking negative sign, the whole things will become positive. And now, so we shall introduce the same. So give a careful observation of a substitution of the things in the above equation number 2 so as to separate the variables. Okay, so minus. So first let me write this term, later on we shall take the remaining parts which are there in equation number 2. So here minus into minus will become plus, so it is 8 pi square mu r square sine square theta by h square. This is the term I have taken, this should be multiplied, and here we have h square p f, and then the denominator 8 pi square mu r square, and remaining things d by dr of r square dr by dr, and minus into minus, again it will become plus, again I'll write the same term 8 pi square mu r square sine square theta whole divided by h square, and here we have h square at the numerator r f we have, and at the denominator we have 8 pi square mu r square sine theta. This much we have, and the remaining thing is d by d theta of sine theta dp by d theta. Okay, and the third term here also minus into minus will become plus. So again I'll write the same part, 8 pi square mu r square sine square theta whole divided by h square, and here we have h square rp at the numerator, h square rp, and at the denominator we are having 8 pi square mu r square sine square theta and d square f by d phi square. And here also we have minus, it will become plus. So 8 pi square mu r square sine square theta by h square. This is the part. And in the numerator we have z, sorry, one more thing I have to introduce over here, rpf, sorry, rpf, 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 so h square, and here this one, right, h square, and as a denominator we have 4 pi epsilon naught r, rpf in the numerator, and the denominator rpf. And here we have positive sign when it comes to, and when we introduce the same term over here it will become minus. We can take that to the left hand side, so it will become plus. So e, so we have 8 pi square mu r square sine square theta e rpf whole divided by h square rpf, and that's whole and solely equals to 0. This is the overall substitution. And now we should simplify this by doing the cancellations. And now give the careful observation for the cancellations of the parts. So here the terms that are there in common. So let me come from here. So 8 pi square mu r square, 8 pi square mu r square will get cancelled. H square will get cancelled. So pf will get cancelled. So we left with sine square theta and r. And here 8 pi square mu r square, 8 pi square mu r square got cancelled. H square got cancelled. rf and rf got cancelled. Sine theta and square got cancelled. So here we left with sine theta and p. And here 8 pi square mu r square, 8 pi square mu r square, sine square theta, h square got cancelled, rp got cancelled. So here left with only f term. Okay, so here rpf will get cancelled, rpf will get cancelled. And now shall write the things that are remained. And here we left with sine square theta by r. So it is sine square theta by r. Sine square theta by r, and remaining part is d by dr of r square dr by dr. Okay, and plus here we left out with sine theta by p, d by d theta of sine theta dp by d theta. And here plus, here we left out with only 1 by f, d square f by d phi square. And plus, here you can observe 8 pi square mu r square sine square theta by h square. 8 pi square mu r square sine square theta by h square is common. So let us take it outside. 8 pi square mu r square sine square theta. Okay. Sine square theta by h square is common. So left with z e square by 4 pi epsilon naught r plus e, that's whole and solely equals to 0. And this is the reduced form. Let me consider this as equation number 3. This is equation number 3. And in this equation number 3, here you can observe this term 1 by f d square phi by d phi square got isolated. So it has only f term. So previously we have written f of phi. So f and phi, this term got isolated. But here you can observe sine square theta and r. Here we have radial and angular term mixed. And here also you can observe theta and radial term. This is also got mixed. So this term can be isolated, and these things which are left behind, those things has to be again simplified so as to separate the variables. So that we shall do now. So here, by keeping this particular equation as reference, the equation 3 what we have got, we need to simplify further. Okay. So here you can observe. So we have the equation number 3 with us. That is this one. And here the term which got isolated is 1 by f into d square phi by d square f by d phi square. This is the equation we got isolated. Okay. So we can say in this way. In equation 5, the f term get isolated. The f term get isolated, so that we can write. So if this got isolated, this will not change. I mean, if any changes in the phi will not alter the remaining part. So these things will remain constant. So we can write the thing as a constant plus 1 by f into d square f by d phi square. So that's equals to 0. So excluding this, all the remaining parts have been taken as constant. So now we can alter this expression once again. So 1 by f into d square f by d phi square, constant will taken on to the left hand side, so it will be minus constant. Since you can observe, so all the remaining terms that what we are having are be some second order things. So let us take the constant as m square. The constant is taken as m square, so that the term will get changed as d square f by d phi square. That's equals to, f can be cross multiplied, so it will be minus f m square. Okay, and here let me consider this as equation number 4, or else this will be re-modified. This equation, the equation will be re-modified. That is d square f by d phi square, minus will be taken to the left hand side, so plus f m square, that's equals to 0. So this I'll consider as equation number 5. And so here we have taken equation number 4, that is 1 by f into d square f by d phi square is equals to minus m square, and this we shall introduce in equation number 3 at the place. 1 by f into d square f by dy square will be taken equals to minus m square. So now we shall introduce the same thing, and we shall do some manipulation so as to get the separation of the variables. Okay, so here the equation will be considered So let us write in this way. So substitute equation 4 in equation 3 and should divide the whole equation by sine square theta. The whole equation should be divided by sine square theta. So now you go with the equation. Now shall consider the equation what we have got for equation 3. So that equation need to be considered. So here this is the equation we got. This is the equation we got. And equation number 3, and that need to be modified, and that we shall do now. So in this equation you can observe, so we need to substitute equation number 4, this one, there's 1 by f into d square f by d phi square, that's it should be taken as minus m square, and the whole equation number 3 is supposed to be divided by sine square theta, and that shall do now. So here by substituting this sine square theta, here you can observe, if you divide by sine square theta, the sine square theta and the sine square theta that comes at the denominator will get cancelled and we'll leave with only r. And when you divide here, this sine square theta and sine theta and 1 square will get cancelled, and here we remain with one more sine theta, and here sine square theta will get cancelled. So all those things can be written in this way. So now the equation will turn to this form. So 1 by r into d by dr of r square dr by dr plus 1 by p sine theta d by d theta of sine theta dp by d theta plus minus 1 by f d square f 1 by f d square phi by d square f by d phi square will be taken as minus m square and dividing by sine square theta plus 8 pi square mu r square sine square theta will get cancelled, so remain with h square of z e square by 4 pi epsilon naught r plus e, and that's equals to 0. And here you can observe these two terms, the first and fourth terms. So we have only the radial terms. And we don't have any angular terms. And here in these two terms we have only p, that's corresponding to theta, and here we have theta. So we got separations. So we can write the expressions separately. So we already got one term isolated, that is phi term. So now we are separating r term and theta term into separate equations. So this will be 1 by r into d by dr into r square dr by dr, and this one plus 8 pi square mu r square by h square into z e square by 4 pi epsilon naught r plus e, that's equals to a constant, right? So that should be equals to a constant. Since we are having minus term, this will become constant. When it comes to the right hand side, it will be becoming positive. So let me take a constant beta. Or else if you multiply the whole equation with the theta term, that is the radial term r, so it will be d by dr of r square dr by dr plus 8 pi square mu r square by h cross square into h square into Z square by 4 pi epsilon naught r plus E, and since we are multiplying with the term r, that's equals to beta r, and this will be taken as equation number 6. So yes, this is the radial term we got separated, and the theta term, that is 1 by p sine theta into d by d theta of sine theta dp by d theta minus m square by sine square theta, that's equals to a constant, and here the constant term is having positive, so when it comes to the right hand side it will be minus. Again the constant will be beta, and if you multiply the whole equation with p, this p will get cancelled, so 1 by the equation with the p, so here this p will get cancelled, so 1 by sine theta into d by d theta of sine theta dp by d theta minus, since we are multiplying with the term p, so m square p by sine square theta, that's equals to minus beta p, and this will be equation number 7. So we got the 3 independent differential equations for r, p and f. So one term we already got, that is d square f by d phi square plus m square is equals to 0, and that is angular term, and this is the radial term, and again we are having one more angular term, this one. So equation 6 is the radial term, equation 7 and the equation 5 what we got. So here we have equation 5. So here d square f by d phi square plus fm square is equals to 0. So this is equation 5, equation 6 and equation 7. So these 3 are the complete solutions of the Schrodinger wave equation what we have derived, that is equation number 3. These are the solutions of equation number 3. Sorry, not for equation number 3, equation number 1. These are the solutions. Equation number 5, equation number 6, equation number 7 are the solutions of the Schrodinger wave equation. Equation number, that is equation number 1, we generated at the beginning. And now when you solve this each equation, that is equation 5, equation 6 and equation 7, we will be getting 3 solutions again, and those solutions will give a clear explanation regarding the properties of electron. And now we shall go with the same. So firstly we shall consider equation 5. So what equation 5 will say? According to equation 5, d square f by d phi square plus f m square is equals to 0. This is according to equation 5. So when you solve this equation, the solution of this equation, solution of equation 5 will gives, I'm not going with the details of the solution, I'm giving the final solution of the equation because it's a very lengthy process. So the solution of this equation 5 will be fm of 5, that's equals to 1 by square root of 2 pi into e to the power of I m 5. This is the final solution of the equation 5. And here the constant we are having, that is 1 by 2 square root of 2 pi. This 1 by square root of 2 pi is the normalization constant of the equation, normalization constant. And here we have one more term, that is m, right? This m can take values 0, plus or minus 1, plus or minus 2. Like this it will take the values, and we actually call this term m as magnetic quantum number. Magnetic quantum number. So We know that the magnetic quantum number, the name of magnetic quantum number is actually given because in presence of external magnetic field, the states of the electron will be having different values for different values of m. And hope you observed, we got one quantum number for analyzing the properties of electron which is present in an atom. And now just for solving equation 5, we got one quantum number, that is m, and now we shall see what we will get if you solve the remaining two equations, that is equation number 6 and equation number 7. So if you solve equation number 6, so what we are going to get, so that we shall see. So equation 6, what actually it gives, equation 6 will actually, according to equation 6, so d by dp of r square dr by dr plus 8 pi square mu r square by h square into z e square by 4 pi epsilon naught r plus e of r, that's equals to beta r. So this is according to equation number 6. So again we have to solve this equation number 6 and the solution of equation number 6. So once again, I'm not going with the details of this equation number 6. So let me give the direct solution of the equation number 6. And here the whole and sole solution, strictly speaking, the normalized solution of this equation number 6. The normalized solution will be r n l of r, that's equals to exponential of minus rho by 2 p of L into L of n plus L and 2L plus 1 of rho. And here we have the term L of n plus L into 2L plus 1 of rho. This is called as, are the Legare polynomials. It is called Legare polynomial, and it is actually defined as L or S of rho is equals to ds by d rho of s into e power rho into d power r whole divided by d rho power r whole and sole multiplied by rho power r into e power minus rho. And here we have the two terms s and r, and here s is actually equals to 2l plus 1 and r is equals to n plus l. And here we have one important term, that is n, and n is actually called as principal quantum number. Principal quantum number, and this principal quantum number will determine the energy of the different atomic orbitals and the distance of the electron from the nucleus. So we got one more quantum number by solving equation number 6, and now we shall go with the last equation, that is equation number 7. So according to equation number 7, it is 1 by sine theta into d by d theta of sine theta dp by d theta minus m square p by sine square theta, that's equals to minus beta p. This is according to equation number 7. And if you solve this equation number 7, we'll be getting the solution. So once again, I'm not going with a detailed solution. So let me write the final solution of equation number 7. And the final solution of this equation number 7 is PLM of theta, that's equals to 2L plus 1 into L minus mod M factorial whole divided by 2 of L plus mod M factorial whole power 1 by 2 into PL to the power mod M cos theta. And here we have one term, that is PL to the power mod M cos theta. This PL power mod M cos theta is called as associated legendary polynomial. Associated legendary polynomial, and which is actually defined as PL of mod M cos theta, that's equals to 1 by 2 power L into L factorial of 1 minus cos square theta whole power mod M by 2 into d power L plus mod M into cos square theta minus 1 whole power L divided by d cos theta whole power of into L plus mod M. And here this whole term, there is one important term that we are observing, that is small l, and this small l is called as azimuthal quantum number. Azimuthal quantum number. And this azimuthal quantum number will determine the exact shape of the orbital in which the electron is present. And apart from that, this azimuthal quantum number also determines the angular momentum of the electron which is present in the orbital. So as a whole and so, we can say by solving the Schrodinger wave equation for the hydrogen atom, we got three quantum numbers n, l and m, which are simply called as n, the principal quantum number, l, the azimuthal quantum number, m, and magnetic quantum number, which mainly gives information about the energy of the electron as well as the distance of that electron from the nucleus. And L, the azimuthal quantum number, will give information about the shape of the orbital in which electron is present. And M will give, that is the magnetic quantum number, will give information about the actual orientation of the orbital in three-dimensional space. And that's about the solution of Schrodinger wave equation when it applied for hydrogen atom. Thank you.